Hello everyone. I would like to thank the organizers of this event and all those who participated in its success, and thus all the participants and assistants. Allow me to present you this communication titled Applications of Artificial Intelligence in Pneumology. The need to improve the health of the population requires us to anticipate and predict health problems in order to be able to act upstream. The great variety between individuals means that each individual has specific characteristics that make him unique, hence the need for personalized medicine. Scientific and technological development in medicine has led to the production of massive data that is difficult to use by humans. All these elements are only possible thanks to the use of machines, especially artificial intelligence. Pneumology, which is a medical specialty that treats conditions that affect the respiratory system, is considered an important source of big data production in medicine, and AI finds its place in this discipline. In particular, in the interpretation of medical imaging, mainly standard radiography and CT scans, and in the interpretation of histoanatomopathological slides, and thus the analysis of pulmonary function tests. The objective is to make a literature review of the different aspects of application of artificial intelligence in pneumology. This is a literature review between 2016 and 2020, searching on direct science and PubMed databases using the keyword artificial intelligence, machine learning, deep learning, and pneumology. It has been observed that AI in pneumology is mainly applied in thoracic imaging, interpretation of histoanatomopathological slides, and pulmonary function tests. The most used models are machine learning and deep learning. These models are used either in classification, for example, classify X-ray as normal or abnormal, or in prediction, for example, predict mortality at 12 years. In thoracic imaging and concerning classification, authors have developed each of them DNAs based on chest X-ray data to source them into normal, non-urgent, urgent, and critical X-ray, or just normal and abnormal X-ray. Other DNAs have been developed to be able to detect lung cancer, tuberculosis, pneumonia, and pneumothorax. The first team found that the model is able to detect normal X-rays with a sensitivity of 71%, specificity of 95%, positive predictive value of 73%, with a fourfold reduction in X-ray transmission time. While in the second study, they obtained a model performance that exceeded those of radiologists and non-radiologist physicians with IC at 0.98. For prediction, many teams have worked especially on long CT images using the DNA as a model to predict survival, malignancy of lesions, or mutation of certain genes, and they have obtained satisfactory results with an IUC ranging from 0.71 to 0.94. Concerning histoanatomopathological slides, teams have been interested in the application of AI in this type of explorations and have developed machine learning and deep learning models to classify or predict from the interpretation of slides a set of abnormalities, especially tumors with IUCs up to 0.99. For pulmonary function tests, machine learning techniques such as decision trees and support vectors or naive classifier have been used to analyze spirometry, plethysmography, and exhaled air volatile organic compound data, and to classify phenotypes of certain pulmonary diseases, or to predict their exacerbations, with performances that sometimes exceed those of pneumologists, as in the case of Topalovic's study. Limits and challenges. The application of AI in pneumology does not escape from limits and challenges that are encountered when putting this technology in practice, namely technical limits, which are many and diverse, and we find among other extrinsic problems, namely difficulty in accessing to data, and sometimes it is necessary to have the authorization of many parties to use it. And when we have access, they are unstructured and unorganized, sometimes on non-computerized files and dispersed, which requires time and personnel to collect this data. And intrinsic problems, in particular the majority of algorithms that have been developed have not been trained to interpret radiological images with multiple pathologies. And sometimes the interpretation is done without taking into account the context of basic clinical information. Sometimes the small size of the lesions, the presence of artifacts, and the loss of resolution when scanning digital images led to some technical difficulties. In some studies, the virtual images used to train the algorithm are not representative of the diversity and heterogeneity of the lesion characteristics. The ethical consideration, which can be resumed in the medical field by confidentiality and professional secret, which imposes anonymity and data coding. Should we impose the Hippocratic oath to the data scientists? Who says ethics, says legal? And there we ask the question of responsibility. Artificial intelligence is the bearer of hopes of exponential progress, but without forgetting that it can be a source of damage in the practice, and that as such it must be assigned a regime of responsibility. In conclusion, can AI replace doctors? In other words, can algorithms replace, for example, radiologists' reports, or can they do the clinical examination instead of the clinician? These algorithms are gaining more and more space in the medical field, and currently they can act in the second place and accompany, help and facilitate the work of doctors. The rapid progress of this technology feeds the hope of having applications more and more enveloped and transforming many aspects in pneumology. Thank you for your attention.